All right, so get this. We're diving deep into industrial panel PCs today. You
Okay.
know those computers you see running things in factories?
Mm-hmm.
Maybe even on a Mars rover someday.
Right.
We're talking machines that laugh in the face of dust storms and heat waves.
Yeah, these things are built to last.
You sent over some fascinating documents about them, so let's decode what makes these things tick.
And they really do tick in some of the most extreme environments you can imagine.
Absolutely not.
Yeah.
I was looking at this product manual, 10.1-inch second-gen I-series panel PC product manual -i3.pdf, and one little detail just jumped out at me.
Okay.
These things can operate in temperatures ranging from -10 degrees C to 60 degrees C.
Wow.
I mean, that's a swing from below freezing to hotter than a desert.
Yeah, that's quite a range.
What kind of sorcery makes that possible?
It's not sorcery, but it is impressive engineering.
Oh?
They have to use specialized components that can withstand those temperature extremes.
Hmm.
And it's not just about surviving, it's about thriving. These computers are running critical systems.
Right.
So even a tiny glitch due to temperature could be disastrous.
Right. Imagine an entire production line shutting down because a computer got a little too warm.
Oh yeah, chaos.
So how do they ensure that doesn't happen?
We'll take a look at the mention of a fanless cooling system.
Yeah.
That's a major factor.
Fanless.
Yeah.
Okay, color me intrigued.
Mm-hmm.
How do they keep things cool without fans?
Well, it is for most computers.
Isn't that like computer cooling 101?
But in a harsh industrial environment, fans become a liability.
Oh.
You have to think about dust,
Yeah.
moisture, all those things,
Mm.
just waiting to clog up a fan and cause overheating.
Right. Makes sense.
Yeah.
So what's the secret sauce in these fanless systems? Some
Ah.
kind of super high-tech heat sink situation.
They use a combination of techniques,
Okay.
like heat sinks, heat pipes, which use a fluid to transfer heat away from critical components,
Mm-hmm.
and designs that maximize natural convection to dissipate heat.
So they've basically engineered a way for the computer to chill out without needing any moving parts that could fail. Pretty clever.
Exactly. It's about reliability in mission-critical situations.
Right.
And speaking of protection, have you noticed the mention of an IP65 rating?
Yeah, I saw that.
Yeah.
But to be honest, those IP ratings always feel like a secret code to me.
Yeah, I understand.
Can you decipher it for us?
Sure, it tells us about the level of protection a device has against dust and water.
Okay.
IP65 means this panel PC is totally dust-tight and can handle water jets from any direction.
So picture this, a construction site covered in dust, maybe even a food processing plant where they're constantly hosing things down.
Exactly.
This computer can handle it all. That's wild.
It is designed for versatility, for sure.
Now, I noticed this manual lists 3 specific models.
Okay.
The IMD101-W200-I3, the IMD101-W210-I3, and the IMD101-W220-I3.
Mm-hmm.
Is it just me, or do those names sound like something out of a sci-fi movie?
Yeah, they do sound a little futuristic.
More importantly, what's the difference between them?
It's all about the touchscreen.
Ooh.
Those model numbers likely correspond to non-touch, capacitive touch, and resistive touch options.
Touch screens that opens up a whole new world of possibilities.
Sure does.
Can you break down those options for us? Why would someone choose one over the other?
Think about the environment and the user.
Okay.
A non-touch screen is the most basic option and might be used in a control room where they're using a keyboard and mouse.
Mm-hmm.
But on a factory floor, you'd want a touch screen. A capacitive touch screen is super responsive,
Right.
but you can't use it with gloves.
I've experienced that frustration trying to use my phone with gloves on.
Exactly.
Yeah.
So for a situation where workers need to use gloves, a resistive touchscreen is the answer.
Okay.
Think of it as a more heavy-duty touchscreen that can handle a bit of force.
So you choose the touch screen based on how and where the panel PC is being used.
Yeah, that makes sense.
That makes perfect sense, but what about the brains of the operation?
Right.
The document mentions Intel Core i3 processors and up to 64 gigabytes of RAM. What does all that tech jargon translate to in the real world?
It means these panel PCs can handle serious tasks.
Okay.
Think about running complex software for automating processes, analyzing real-time data from hundreds of sensors, and even controlling robotic systems. All of that requires some serious processing power.
Wow. It's amazing to think that all of this is happening inside a machine that's designed to be basically indestructible. It's like the ultimate combination of brains and brawn.
And that's precisely what makes them so valuable in industrial settings.
Right.
You need a machine that can not only survive the environment, but also keep up with the demands of increasingly complex tasks.
Speaking of which, let's talk about those tasks. What are some real-world examples of how these panel PCs are being used?
Oh, there are tons of
I'm
examples.
imagining everything from controlling robots to monitoring critical systems.
You're spot on.
Yeah.
Let's dive into some of those fascinating use cases right after this.
All right, so we've established that these industrial panel PCs are basically the superheroes of the computer world. Tough, smart, and ready to take on any challenge. But let's get specific.
Okay.
Where are these digital workhorses actually flexing their muscles?
Picture a massive manufacturing plant
Okay.
where robotic arms are assembling cars with incredible precision.
Wow.
An industrial panel PC could be the brain behind that entire operation,
Okay.
coordinating the movements of the robots, monitoring sensors for any issues, and ensuring the whole process runs smoothly.
Wow. So we're talking about a level of automation that was practically science fiction just a few years ago. That's incredible.
It is.
Yeah.
And it's not just about automation.
Okay.
These panel PCs are also used for things like quality control,
Right.
where high-resolution cameras and image processing software can detect even the tiniest imperfections in products.
So they're not just building things.
Right.
They're making sure those things are built perfectly. That's fascinating.
Absolutely. And it's not just limited to manufacturing.
Right.
Think about energy production, oil rigs, wind
Yeah.
farms,
Okay.
even nuclear power plants.
Yeah.
These panel PCs can be found in control rooms, monitoring critical systems, collecting data, and helping operators make crucial decisions in real time.
I'm starting to see a pattern here. It seems like anywhere you need a computer that can handle a demanding job in a less than ideal environment, these panel PCs are the go-to solution.
Exactly. They're also being used in transportation logistics, healthcare, you name it. The possibilities are pretty much endless.
Now, this product manual mentions a wide range of connectivity options.
Right.
LAN, HDMI, USB, VGA, even RS-232. It's like they threw every possible connection type into the mix.
It seems that way.
Why so many options?
Well, it's all about flexibility and integration.
Okay.
These panel PCs need to be able to talk to other devices, networks, and systems seamlessly.
Right.
LAN allows them to connect to the local network. HDMI or VGA lets you hook up external displays for monitoring or presentations.
Okay.
And USB ports are essential for peripherals like keyboards, mice, and storage devices.
Right. It wouldn't be very helpful if this supercomputer was stuck in its own little world and couldn't communicate with anything else.
No, not at all.
So what about that RS-232 port you mentioned? Isn't that a bit outdated?
For most consumer devices, yes.
Yeah.
But in industrial settings, it's still widely used for connecting to legacy equipment and machinery.
I see.
A lot of older industrial systems rely on RS-232 communication,
Right.
so having that compatibility is crucial.
So they've basically made a computer that can speak the language of both the old and the new? That's some impressive versatility.
It is, and it highlights the importance of backward compatibility in these industrial applications. You can't just rip and replace all the existing systems overnight.
That makes perfect sense. Now let's talk about operating systems.
Okay.
The document mentions support for Windows, Ubuntu, and CentOS.
Yeah.
Why offer such a variety? Why not just stick with the most popular one?
Different operating systems have different strengths and weaknesses, and the choice often depends on the specific application and the user's preferences.
Okay.
Windows is familiar to many and has a vast software ecosystem,
Right.
making it a good choice for general-purpose tasks. Ubuntu and CentOS, on the other hand, are Linux-based systems,
Okay.
known for their stability, security, and open-source nature.
So it's like choosing the right tool for the job.
Exactly.
Sometimes you need a Swiss Army knife, and sometimes you need a specialized tool.
Right. And in industrial environments, security is a paramount concern.
Right.
And that's where Linux-based systems like Ubuntu and CentOS can really shine.
Okay.
Their open-source nature allows for greater transparency and control over the code, making them less vulnerable to certain types of security threats.
So it's not just about which operating system is the coolest or the most widely used. It's about choosing the one that best fits the security and functionality needs of the specific application.
Precisely. And it's important to note that the choice of operating system can also affect the panel PC's compatibility with certain software and hardware.
Right. It's all about finding the right balance between functionality, security, and compatibility.
Exactly. And that brings us to another crucial aspect: reliability.
Okay.
We touched on this earlier, but I want to dive a little deeper.
Please do. I think it's easy to overlook the importance of reliability when you're talking about computers. We're so used to things occasionally glitching or crashing, but in an industrial setting, that's simply not an option.
Exactly. In a factory, a power plant, or any other critical infrastructure, downtime can have a domino effect,
Oh, wow.
leading to lost production, financial losses, and even safety risks.
Right.
These panel PCs are designed with redundancy and fail-safe mechanisms to minimize the impact of any potential issues.
Redundancy and fail-safe mechanisms. Can you elaborate on that?
Sure, redundancy means having backup systems in place so that if one component fails, another one can take over seamlessly.
Oh,
For example, a panel PC might have multiple hard drives configured in a RAID array,
right.
so that if one drive fails, the data is still protected and accessible.
That's like having a spare tire in your car. You hope you never need it, but it's there just in case.
Exactly. Fail-safe mechanisms are designed to prevent catastrophic failures.
Hmm.
For example, a panel PC controlling a critical process might have a built-in safety shutdown feature that kicks in if certain parameters go out of range,
Okay.
preventing damage to equipment or harm to personnel.
So they've thought of everything from the hardware to the software to make these things as bulletproof as possible. It's really impressive.
And it highlights the level of engineering and attention to detail that goes into designing these industrial-grade computers. They are a far cry from your average consumer laptop.
Speaking of consumer laptops, I can't help but wonder about the future of these panel PCs.
hmm
As technology continues to evolve at a breakneck pace, what do you think the next generation of these rugged machines will look like?
That's a great question, and one that engineers and innovators are constantly exploring.
So we've got these super reliable machines already tackling tough jobs, but what's next? What's on the horizon for industrial panel PCs?
Well, one area that's really exciting is the integration of artificial intelligence and machine learning.
AI.
Yeah, we're already seeing panel PCs used for tasks like predictive maintenance,
Oh, wow.
where they analyze data from sensors to anticipate potential equipment failures before they happen.
That's incredible. It's like they're developing a sixth sense for machinery.
It is, and as AI and machine learning algorithms become even more sophisticated, we can expect to see panel PCs taking on even more complex roles in industrial automation and decision-making.
So instead of just reacting to problems, they'll be able to anticipate and prevent them. That's a game changer.
Absolutely. Another area of innovation is in the realm of connectivity.
Okay.
As the industrial Internet of Things, IoT, continues to grow,
Right.
we'll see even more devices and sensors connected to panel PCs, creating a vast network of data and control.
That's right. It's not just about the panel PC itself, it's about how it fits into this larger ecosystem of connected devices.
It's exactly. We can expect to see even faster and more reliable wireless communication technologies, allowing panel PCs to communicate seamlessly with other devices, even in remote or challenging environments.
So we're talking about factories that are constantly monitoring and optimizing themselves,
Right.
power grids that can adjust to changing demands in real time,
Mm-hmm.
and transportation systems that are safer and more efficient than ever before.
Exactly. It's an exciting time to be following this technology.
Yeah, it really is.
And of course, we can't forget about the physical design of these machines
Right.
as we push further into extreme environments.
Right, like even tougher than what we've been talking about.
Exactly. Think space exploration, deep sea operations.
Oh, wow.
We'll need even more rugged and resilient panel PCs.
You're right, those environments demand a whole other level of toughness.
Yeah.
What kind of advancements are we talking about?
Material science is playing a key role. We're seeing the development of new alloys and composites that are lighter, stronger, and more resistant to extreme temperatures, pressure, and even radiation.
So imagine a panel PC that can withstand the scorching heat of Venus or the crushing depths of the Mariana Trench. That's mind-blowing.
It is, and as 3D printing technology advances, we may even see panel PCs that are custom designed and manufactured on-site, perfectly tailored to the specific needs of each application.
That opens up a whole world of possibilities. No more one-size-fits-all solutions.
Exactly, and the future of industrial panel PCs isn't just about hardware and software.
Right.
It's also about the people who use them. We can expect to see more intuitive and user-friendly interfaces, making it easier for operators to interact with these complex systems.
Right, because even the most advanced technology is only as good as the person using it.
Absolutely. It's all about finding the right balance between cutting-edge technology and human expertise.
Well, it sounds like the future of industrial panel PCs is bright, filled with innovation and exciting new possibilities.
I couldn't agree more. It's a field that's constantly evolving, pushing the boundaries of what's possible in industrial computing.
It's been fascinating exploring this world with you. We've learned about the incredible resilience of these machines, their vital role in keeping critical systems running, and the amazing innovations that are shaping their future.
It's been a pleasure sharing these insights.
And for our listeners who have been on this deep dive with us, we hope you've come away with a newfound appreciation for the unsung heroes of the industrial world. the industrial panel PCs.
Indeed, they may not be as flashy as the latest smartphones or gaming consoles, but their impact on our world is undeniable.
So the next time you see a factory humming with activity, a power plant providing energy to a city, or a robot performing a complex task, remember the industrial panel PC, the brains behind the brawn. Until next time, keep exploring, keep learning, and keep diving deep into the world of technology.